Hi, my name is Martin Gindel, and this is my 2025 archival video for Phase 1 of my long-term 3D printable fusion reactor project. The end goal of this project is to facilitate sustainable energy research and education by designing an affordable fusion energy teaching aid. Now, I'm going to achieve this by creating a Fusor system around a cheaper vacuum chamber by making it metal 3D printable. Now, this is very innovative compared to normal solutions, as in traditional high vacuum applications, everything is standardized and incredibly expensive, unless you're willing to machine it yourself, in which case material costs will be cheaper, but it would require hundreds of thousands of dollars worth of equipment and hundreds of hours invested in learning how to use it, and likely 20 to 30 hours of machining on its own. With metal 3D printing, this vastly expands the geometric possibilities and options you have in terms of shape, size, and other integrations such as internal cages or geometries that allow you to shed heat better, which are going to be applied in my current project. Now, Phase 1 aimed to design a Fusor system. So basically create a diagram of how a Fusor works, create a detailed parts list, which I did, and to start prototyping vacuum chambers in plastic. Now, I first started prototyping with PLA on an FDM 3D printer, which couldn't hold a vacuum due to the air between the layers. Then, after compiling all my research and putting it into a presentation, I was able to acquire $1,000 from a venture capital fund. This allowed me to invest in a resin 3D printer, which vastly expanded my material capabilities. I was now able to 3D print fully vacuum capable parts and experiment with them, which led to my current setup. Now, this setup, though I wasn't able to test it, due to the ripcord deadline, should in theory be able to allow me to achieve a vacuum in a 3D printed part, which, though it is not metal, it uses a similar enough process to where it should be applicable as well. Now, this project taught me many things, but most importantly, I learned about presentational skills. Compiling months and months of research into a slideshow and explaining it to someone who does not understand much of what you're saying is incredibly difficult. And through much trial and error, I was able to fully understand this process and apply it successfully to my project. After the end of Phase 1, I was able to achieve another $5,000 grant via these presentational skills. So they've taught me so much. Now, this project relates to the elements of atoms, as this is a fusion reactor, and I needed to master the ability to understand fusion, how it works, and all the components related to it. Engineering, as I had to experiment with different manufacturing methods and materials. And of course design, as I had to 3D model the project and share the designs with others in an intuitive and easy to understand way. Thank you so much for listening to my presentation, and I hope you see me here again soon. Thank you so much. Goodbye.